Good morning, good afternoon, or good evening. This is Senior 3 Mathematics, Sequences and Series. If you remember clearly, I said we shall solve sequences and series in two phases. The first phase, which is complete now, is the phase of sequences. And now the second phase is the phase of series. And a quick reminder, this is Vision Plus, and if you find these materials resourceful to you, then share them with your friends. Alright, under series, we have two concepts that we are going to look at basically. And what I can tell you is that series is where there is a lot of content. Unlike sequences, in series, we shall learn a lot of things. So prepare yourself and we go in. So, by definition, a series is formed by adding the terms of a sequence together. We add the terms of a sequence together. Remember we said a sequence is a set of ordered lists of numbers that are arranged in a particular manner or in a particular pattern following a particular rule. But now in this case, the addition of the terms or the addition of the numbers of a sequence forms what we are calling series. That is what a series is. For instance, if a sequence is U1 for the first term, U2 for the second term, U3, and the sequence continues up to the nth term, UN. This is just a sequence. Then the corresponding series is the addition of the terms or the numbers of this sequence, and therefore we shall say U1 plus U2 plus U3 plus we keep on adding the terms up to the last term UN. That is what a series is. It is simply the addition of the terms of a sequence. What we obtain after adding the terms of a sequence is what we call a series. That is the definition. Now, the sum of the first n terms is denoted by Sn. So anywhere you see Sn, it means the sum of n terms of a given series or of a given sequence. That is Sn. That is the sum of n terms, where n varies. If you are looking for the sum of the first two terms, your n is 2. If you are looking for the sum of first 5 terms, your n is 5. Depends on the terms in consideration. And therefore, the sum of n terms becomes u1 plus u2 plus u3 up to the term un, which is the nth term that you are looking for or your last term in question. And then we have an example right here. The example is that we are given a sequence. A sequence is given as 1, 2, 3, 4, 5, and the sequence continues. Now, what is the sum of the first one term? The sum of the first one term is itself. That's why the sum of the first one term is 1, because it is alone. And the sum of the first two terms, it now becomes 1 plus 2, because our n is now 2. So we say S2 equals to 1 plus 2, and it gives us 3. That is the sum of the first two terms. And the sum of the first three terms becomes 1 plus 2 plus 3, and it gives us 6. Those are the first three terms. And finally, for this example, the sum of the first four terms, you just get the first four terms and add them. 1 plus 2 plus 3 plus 4, and it gives you 10. Even if you are looking for the sum of the first 5 terms, S5, it becomes 1 plus 2 plus 3 plus 4 and then plus 5. And then you add them, and that gives us 15. That would be the sum of the first 5 terms, which this example has not quoted. So the key thing is that keep in mind that Sn is the sum of the first n terms, and n varies depending on the number of terms that you like to consider. Yes, this explanation is not complete, and as we go further, we shall keep on adding additional knowledge. So keep in mind that we still have more to learn. And I encourage you to sit down, copy these notes, and have them for your revision. So what is the key point here? We have said that a sequence is an ordered list of numbers, while a series is the sum of the terms of that sequence. As we have said, the sum of the first n terms is written as Sn. So that is the brief definition and examples and definition of terms that we need to know under series. Now, there are two types of series that we are going to look at one at a time. The first type is what we call the arithmetic series or the arithmetic progression. That P stands for progression. So there are two types of series that we look at. One is the AP series or the arithmetic series, and two is what we call the geometric series or geometric progression. We shall look at it shortly. And in this phase, what I am doing right now is defining the terms. I'm laying the foundation for your understanding of the subsequent content that we shall have in this topic. So by definition, arithmetic series, the sum of the terms of an AP where consecutive terms differ by a common constant or by a constant value that we call a common difference. So remember, there are two types. How do you distinguish between them? The distinguishing feature is that arithmetic series has a common difference between any two consecutive terms. That is the point under AP. If there is something that you take away from this class at this moment is an AP series is defined by the common difference. And for example, we have a series a plus d plus a plus 2d, and it continues. You may not be in position to visualize this right now, and the best explanation comes when I get to the example. So this is just a series. The sum of the first n terms of an AP is given by the sum Sn equals to n out of 2 into 2a plus n minus 1 times d. Keep this formula in mind. Write it somewhere. You must always know this formula. Or it is the same as n out of 2 into the first term plus the last term. That is very important. Keep that in mind as well. And this is the definition of terms. A is the first term. Remember, under sequences, we were saying U1 is the first term, right? Yes. And still in this case, we shall say u1 is the first term, and u1 is the same as a, which is the first term. These two can be used interconvertibly. They are the same. So if you see a, that is the same as the first term u1 only. And then by defining terms here, the d that we see in the formula is for the common difference. L is the last term, n is the number of terms. Let us look at this example. We are given a sequence 2, 5, 8 and continues. And what series do we form from here? The series that we form is simply by addition of the terms of the sequence. That is 2 plus 5 plus 8. You simply add them. How do we know that this is an AP series? Because this AP series, we say there is a common difference D, which is a common difference of terms, right? That simply means that every term differ from the next by a common number. Like for example, if I get the first common difference D1, that is a difference between 5 and 2. So 5 minus 2, I get 3. If I get the next common difference, that becomes 8 minus 5. 8 minus 5, and it gives me 3. Are you saying there is a common difference of any two consecutive terms? If I get the next difference D3, it becomes 11 minus 8, and that gives me 3 again. If I get D4, it becomes 14 minus 11, and that still gives me 3. That's why we are calling it a common difference. Every term differs from the next by a common number as any other consecutive terms. So that is the takeaway in your mind, that if for it to be an AP series or arithmetic series, then the consecutive terms must have a common difference. That is the distinguishing feature that you will take away. We have taken time here, and I remember saying there are two types of series. So in the next video, I am going to explain the next type of series that we call the geometric progression. Otherwise, thank you. Keep your notes and keep on following until we reach the examples. By the time you do 5 examples, you will be a senior in series. Otherwise, thank you, and this is Vision Plus.